Hello! Today, in this video, I will be explaining the science and innovation of electroplating to you guys. Ready? Let's go! First, before we start, some may ask what is electroplating in the realm of chemistry? Well, electroplating is a process where metal ions migrate from a positive electron to a negative one through a solution. An electric current drives this process, causing objects and the cathode to be coated by the metal in the solution. For better illustration, please look at the VCR. Let us look how a plating pad is composed. First, it starts off with a power supply to electrical level and solution. The electrical stage is composed of an anode and a cathode. The anode loses electrons in the reaction and an oxidation reaction occurs, while the cathode gets electrons during the reaction. This phenomenon is a reduction reaction. The anode is connected to the positive pole of the power supply. The cathode is connected to the negative pole of the power supply. From the picture, the anode is on the left side of the picture. It is the metal to be plated. On the right side would be the cathode, which is the workplace to be plated. Now, let us have a closer look at some of the applications that uses electroplating. Electroplating is crucial in many industries, such as car parts like bumpers, door handles, and grills, are electroplated to prevent rust and corrosion, ensuring durability and an aesthetically pleasing finish. Jewelry often undergoes electroplating with metals like gold, silver, and rhodium to enhance its appearance and protect against wear and tarnish. In electronics, components like connectors and circuit boards are electroplated with metals such as gold and nickel to improve conductivity and resistance to oxidation. Kitchen utensils and cutleries are also electroplated, often with chromium, to provide a shiny, corrosion-resistant surface that is easy to clean. However, despite its benefits, electroplating involves significant risks due to the hazardous substances used. Common hazard materials in electroplating include the following. Let's go and take a look. First is the heavy metals. Heavy metals refers to when the density of a metal is higher than 5. Some of them include lead, cadmium, nickel, and chromium. Lead and cadmium are particularly toxic and can cause several health issues, including neurological damage and kidney failure. Nickel can cause allergic reactions and respiratory problems, while hexavalent chromium is known carcinogen. The second one will be acids and bases. Strong acids such as sulfuric acid, hydrochloric acid, and nitric acids are often used in cleaning and etching processes before electroplating. These acids can cause severe burns and respiratory issues if proper safety measures are not followed. The third one will be cyanide solutions. Cyanide is used in certain electroplating baths, especially for gold and silver plating. It is extremely toxic and can be fatal if inhaled, ingested, or absorbed through the skin. For the last one, it will be metal dust. During post-processing after electroplating, the cutting of the materials may result in metal dust flying around in the air. If inhaled, it would have significant negative impact on the respiratory system of humans. These points will result in negative impact on our human body. There are two categories of problems, which is short-term and long-term. Short-term health problems refers to burn, lung problem, and eye irritation, while if long exposure to it will cause long-term health problems, which include nerve disorder, asthma, or even cancer. Moving on, now I'm going to talk about when chemical exposures may occur. Chemical exposure in electroplating can occur during several stages. They are: chemical exposure can occur during the preparation stage when workers are handling and mixing chemicals used in electroplating baths. This can lead to skin contact or inhalation of fumes, especially if proper protective equipment is not used. During the electroplating process, when parts are immersed in the electroplating baths, there is a risk of fumes and splashes occurring. This can result in inhalation of toxic vapors or skin contact with corrosive chemicals. After the electroplating process, during the post-processing stage of rinsing and drying the electroplated parts, there is a potential for the release of residual chemicals. This can occur if proper ventilation systems are not in place, or if workers do not follow correct waste disposal is another stage where chemical exposure can occur. Handling and treatment of chemical waste can expose workers to concentrated hazardous substances, leading to potential skin irritation, respiratory issues, or other health concerns. It is essential that proper training and protocols are in place to minimize the risk of chemical exposure during all stages of the electroplating process. This graph illustrates the levels of nickel exposure in urine of workers, indicating that chromium and nickel compounds are primarily excreted through urine after being absorbed. The graph demonstrates the significant presence of nickel and chromium in workers' urine, highlighting the hazardous substances that workers are typically exposed to during their work. The graph also indicates that workers are being exposed to toxic level of nickel, suggesting real risks associated with electroplating processes. After we had talked about the risks and hazardous substances during electroplating, now we're going to talk about things that we could minimize these risks. In order to mitigate these risks, industries implement strict safety measures. These would include the following. The first one would be proper ventilation, ensuring that work areas are well ventilated to disperse harmful fumes and reduce inhalation risks. The second one would be protective gear. Workers wear appropriate personal protective equipment, also known as PPE, such as gloves, goggles, and respirators, to prevent contact with hazardous substances. As a result, if chemical spills, it could protect the workers from getting harmed. The third one is regular monitoring of the lab or the place that workers used for electroplating. Continuous monitoring of air quality and exposure levels in order to ensure they remain within safe limits for use. For our next segment, I will be explaining the scientific and technological innovations from electroplating. Electroplating represents a significant scientific and technological innovation, aligning with our key concepts of system and related concepts of patterns. Innovation in electroplating aim to enhance efficiency and reduce environmental impact. For instance, pulse electroplating, where current is applied in pulses rather than a steady flow, can improve the quality of the coating and reduce the energy consumption. Subsequently, I will be evaluating some alternatives in regards to electroplating. There are two alternative methods to electroplating, which are physical vapor deposition, also known as PVD, and chemical vapor deposition, known as CVD, offer different benefits and drawbacks.
A few moments later.
For our final segment in this video, I will be explaining the social, economic, and environmental factors that are impacted by electroplating. Electroplating has significant social, economical, and environmental implications. Economically, it supports industries and jobs, contributing to technological advancements and product longevity. Socially, it impacts communities near industrial sites through job creation, but also poses health risks if safety standards are not maintained. Environmentally, it poses challenges due to the potential release of hazardous waste, requiring strengthening regulations and sustainable practices to mitigate negative impacts. This brings us to the end of this video. In conclusion, electroplating is a complex process with wide-reaching implications. Through scientific and technical innovation, we can continue to improve its safety and sustainability, ensuring it remains a valuable industrial process.